Now, I'm sure something like this has happened to you before. It's Monday morning, you have your hot beverage in hand, and you open your code review tool to find that your teammate has submitted a pull request with 47 changed files. You start reading and realizes it fixes a time zone bug in your invoice class, renames a handful of methods across the billing module, and adds a brand new discount feature, but all in one pull request. The trouble is it's putting a lot on you to do this review. Do you feel confident you can safely deploy the changes to production without it causing issues? Can you revert the discount feature if it causes problems without losing the bug fix? The answer is no, because everything is all tangled together. This mess is going to take a long time to review if you don't just click approve out of laziness, and it's going to cause this pull request to get stuck into review purgatory. And it happens on teams everywhere. If only there was a better way. Hello, developers, and welcome to the PHP Architect channel. I'm Scott Keckborn, and today we're breaking down the anatomy of a great pull request so your code gets reviewed faster and deployed with confidence. If you're new here, we cover topics related to the PHP ecosystem. Make sure you hit that subscribe button so you don't miss the next one. What we can do to solve this kind of a problem is make sure that our pull requests are atomic. And at a very high level, atomic pull request is much like an atomic commit in that it does exactly one thing. You can think of it like the single responsibility principle, but for your version control workflow instead of classes. A bug fix is one pull request, a refactor is another, and a new feature is yet a third pull request. Keeping your pull requests atomic will make it easier for reviewers, either AI or human, to review your code, which will make them happier and more likely to approve them without a bunch of nitpicky changes. Atomic PRs can be easily rolled back because you're affecting a smaller number of files. And finally, atomic pull requests make it easier to figure out what changed when your CI/CD pipeline fails. That messy invoice example from earlier should have been at least 3 separate pull requests. One to fix the time zone bug, which might only be a single line change. A reviewer can easily verify the fix in under a minute, approve it, and the team can deploy it immediately. If something goes wrong, rolling it back is trivial. Another pull request to rename the methods because the change is mechanical and predictable. A reviewer knows that every change in this PR is a rename and can easily see the change, and paired with something like PHP stan, you can verify that they're all correct. Though again, this can quickly be approved. Finally, the new feature gets its own PR with its own tests, its own description, and its own review cycle. If the product team decides to delay the discount feature, then the bug fix and the rename are already deployed and safe in your production code. So you'll find that there's no magic number for how many lines a pull request should change, but you'll find that the smaller the pull request is, the faster the reviewer can look at it and quickly give up a thumbs up with minimal effort on their part. So here are some practical strategies for keeping your pull requests small. The first is splitting by layer. So if you're adding a new feature that changes your database schema, business logic, and UI, you can split that into 3 different pull requests by layer. First, the database migration and the model changes, then the business logic, and then finally the UI. You'll be able to create tests at each layer that drives the changes, which will also make it easier for your reviewer. Now, the downside to this is that you might have to make sure that your existing code works with the changes, and you might have to go through and backfill missing data, but it's still worth the effort and time to do all of this. If you spot some messy code while working on something unrelated, don't clean it up in the same pull request, as is our normal urge as developers. Instead, make a note of it, finish your work, and submit the refactor as its own pull request. Your reviewer will then easily evaluate whether the refactor is correct without also thinking about your new feature or bug fix. If you realize you need to refactor before you make this change, pause your work, do the refactor, and then resume your work. So one of the things that can be especially challenging is if your feature takes multiple pull requests to complete, you can't just deploy it into production and hope for the best. Instead, you can wrap it behind a simple feature flag so that you can merge incremental pieces without exposing incomplete functionality to your users. Working with feature flags is a video of its own, so I'll leave you with just this quick example on the screen. I think it's important to remember that atomic commits lead to atomic pull requests. If you practice making small focused commits as you work, splitting your changes into atomic pull requests become a no-brainer. Each commit should represent one logical step, and when it is time to create your pull request, you have a clean boundary between changes and can quickly create a stack of pull requests that the reviewer can quickly review. On the other hand, if you make one giant commit at the end of the day with a message like work, splitting that into multiple pull requests becomes painful. Not impossible, but painful. Building good commit habits makes good PR habits almost automatic. We'll have more after this word from our partners.
Building PHP applications is your passion. Managing cloud infrastructure shouldn't be your headache. Displace is your partner in cloud infrastructure orchestration, giving solo developers and small teams the tools and automation to deploy enterprise-grade Kubernetes clusters without enterprise-grade complexity or cost. Their CLI tool streamlines everything from local development to fully managed cloud deployments on AWS, Azure, GCP, and more. Skip the steep learning curve of Docker, Kubernetes, and Terraform. Let our automation free you to focus on your core business without losing control over your infrastructure. Get started at displace.tech and discover how the right tools can eliminate the need for a full DevOps team.
Your pull request description is your chance to give reviewers the context they need to evaluate your changes without a bunch of back and forth. Submitting a blank description requires the reviewer to reverse engineer your intent from the code alone, which is slow and error prone. They might be annoyed at you and just reject the PR out of spite. Not that I've ever done that. A strong PR description answers 3 questions. What changed, including a brief summary of the technical changes. Try to keep it to 2 or 3 sentences so you're not writing a novel. Why did it change? Including a link to the issue, bug report, or product requirement is great, but adding a short, maybe even one-line explanation of the motivation helps reviewers understand what's going on. It will also help future developers understand why something is done if you change issue trackers and the reason is lost time. And then finally, how the reviewer can verify it, including testing steps, screenshots, and expected behavior. This is especially important for UI changes or complex business logic. On the screen is an example of a really solid PR description without too much information. Notice how this description tells the reviewer exactly what to look for, why the change matters, and how to confirm it works. That kind of clarity turns a 30-minute review into a 5-minute approval. So there are a lot of common gotchas that will get you if you're not careful. You might just say, I'll sneak in this small fix, but it's never really a small fix. Mixing changes makes it impossible to revert one without reverting the other, and it makes your Git history harder to search later. Saying, but these changes are related. Related is not the same as inseparable. A bug fix and a feature might relate to the same module, but they serve different purposes and should be reviewed independently. Splitting this into multiple pull requests will take more time. It may feel that way at first, but smaller PRs get reviewed faster, have fewer revision cycles, and cause fewer merge conflicts. The total time from code written to code deployed is almost always shorter. Saying my team doesn't review pull requests anyways. Even if you're a solo developer, atomic pull requests make your Git history a useful debugging tool. 6 months from now, Git bisect will thank you for keeping your changes focused. As a brief recap, an atomic pull request does exactly one thing: one bug fix, one refactor, or one feature. Keep your pull requests small whenever possible for faster, higher quality reviews. Good commit habits make good pull request habits almost automatic. Write pull request descriptions that answer what changed, why it changed, and how to verify it. I hope this breakdown helps you create better pull requests that your reviewers actually enjoy reading. So here's my question to you. What is the worst pull request you have ever had to review, and what made it so painful? Drop your horror stories in the comments below. I read every single one, and your experiences help me create better content for this channel. If this video helped you rethink how to structure your pull requests, make sure you subscribe and share with your teammate who might need to see this. It generally helps others discover the channel. This is Scott Keck Warren for the PHP Architect channel signing off and reminding you to keep watching, keep coding, and keep reading.